Greetings, ladies and gentlemen, and welcome to week 13, our third week of online schooling. Hopefully you are doing well. I know a lot of teachers are just launching their online program today, so your schoolwork may be adding up. So ours is going to slow down just a bit in chemistry. We're not going to do the daily lectures like we did during week 10 or the 3 lectures like we did during week 11. This week we're going to focus on your fourth quarter project. It looks like it's going to be a rainy week, so your project may have to be indoors, as you can see out there. See all that rain coming down? It's probably raining in Fontana too. I live out here in San Bernardino. So I'm going to go ahead and we are going to jump into talking about your project. The project, as you can see, is not just for CP chemistry, but it's for all the chemistry classes. This is a project that CP chemistry will be doing, honors will be doing, and living by chemistry will be doing. And this is the fourth quarter project that we had originally planned for you to do in class in front of your classmates, showing them some cool chemistry. Or you're still going to do the cool chemistry, but you're going to be doing it at home, and you're going to be recording that either by video or photo documentation. So I will talk a little bit about that. I want you to have your handout out. Make sure you've downloaded the handout and you're listening to this and taking notes on your handout. So take out a pen, take out your handout, take out a highlighter so you can highlight important things as we go through. And then you can come back to this video if you need reference, like what did she say? What was I supposed to do on this part? And then, of course, I'll talk about how you can submit questions for clarification as we go through the project. So have your handout there, either on your laptop, saved in a way that you can write on it, or print it out if you happen to have a printer at home. I personally don't have a printer at home, so I can't do something like that, but I can make notes on a document by saving it as a Word doc or a PDF doc. So find out a way that works for you, or take out a separate sheet of paper to write your notes on. Whatever works for you. I know we all have different arrangements at home, so that's going to be different for all of us. All right, so what we're doing here is we're going to be doing some, as you can see, I'm just going to read through and talk a little bit through this, some of our own independent research and investigation. It's going to be hands-on, which means you actually have to do the experiment. It's not just a research project. All right, you're going to have to show in your discussion and your writing that you've learned some basic chemistry concepts this year. And that's going to include both your vocabulary, the words that you use, and the way that you write those words. And you're going to be doing this chemistry project using basic household things. Some of you may order a few things online, but for most of you, it's going to be stuff that you're going to have at home. And the main goal here is you are going to teach the concept. So not only are you going to prepare a demonstration, but you're going to use that to teach a concept. And as you teach the concept, that's going to show me if you really understand the concept. And that's what I'm looking for. So phase 1 of our project, and this is this week's portion. I'm going to go through all the phases, but this week's portion is what I'm going to focus on today. Phase 1 of the project, as you can see here, get a highlighter here. Phase 1 of the project is you are going to research. So this week is focused on research, and you're going to research chemical demonstrations that you can safely do at home. You're going to do that research on the internet, or you can use your textbook as a reference. You don't have a very much good bandwidth or anything like that. You can use a cell phone to do that research. You're going to narrow down your research to demonstrations to which you have access to the materials. This is a key one, because normally you might be able to borrow some stuff from me in the lab, but now that we're at home, you won't be able to do that. So it's going to have to be stuff that you can get your hands on. All right, if it has 5 things that you need and you only have 4, you don't have the 5th one, then you can't do that demo. You have to find another one. So for all of us, that's going to be different. If you have pool supplies because you have a swimming pool, you might have some chemicals somebody else wouldn't, right? If you know somebody who's into agriculture or they're landscapers, they might have chemicals somebody else wouldn't, right? Depending on your parents' profession, they may or not have access to chemicals, depending on your ability to use Amazon or have the resources for that. But believe me, there are plenty of chemicals that you can use at home without buying anything or ordering anything. That's really just if you want to get into a little more technical or have a wider variety of options. But everything should be able to do stuff that you can have at home. Okay, so you're going to narrow down to ones that you actually can do because you have the supplies. And then you're going to do some research. You're going to research 3 of the chemical concepts. So now you know what the demos are. Now your job is to figure out the chemical concepts. And many of your points for this project come from your understanding of the chemical concepts. So let's look. This is what we're talking about here. What is the chemistry behind that demo? Why does it work? Right? There's a demonstration called the 7 layers. And each layer has a different color, and they all sit on top of each other. You may be thinking, oh, I think I saw that in elementary school, or I think somebody did that in middle school as a project. It's true. But what makes it a high school project? Well, not just your ability to create the 7 layers, but your ability to tell, why aren't those 7 layers mixing? Why does one sit on top of each other? And so you'd be look at the concepts. What are the concepts here? Density? Yeah, density is one concept, but it's not just density. It's also polarity. What is polarity? What is polarity that causes those chemicals to stay separate in the jar, right? Why are they one on top of the other in that order? So that's what we're talking about, chemical concept. Looking behind the thing that's interesting and figuring out what's the chemistry that makes it happen. So I want you to do this week, this is your task this week, is you're going to do at least 3 of those. All right, so 3 is your goal. And you're going to rank those 3 in order of preference, right? Which one of these do I prefer to do? You're going to rank them in order of preference. You can see that it says right here. This is your assignment for this week, to do the research and then rank them, and then submit that research and those rankings to me on Teams by April 13th. Okay? By April 13th. So right here, April 13th is a week from today. It's by next Monday. And then I will reply to you and let you know which one has been approved. I'll try to give you your first choice, but if a couple other people have taken that first choice, then I'll give you your second choice or your third choice. All right, so this is it. This is your work for the whole week. You can imagine you've got 5 days, right? 5 days of homework, all in this one assignment right here. So you can spend as much time or as little time, just depending on how detailed you want to get. So that's all you're doing between now and next Monday. All right, I'm going to go ahead and go through the next parts of the project, go overview the whole project, but I'll come back next Monday with more details on phase 2 and phase 3. So I'm going to quickly go through them today. All right, let's go ahead and go to phase 2. Phase 2 is where you're going to be practicing. This is your week 13. No, we're on week 13 now. No, we're 12. Week 13, we'll be practicing the demonstration, practicing it at home, making sure you can get good at it. There's a demonstration called Egg in a Bottle that people can make happen once or twice, and then when they try to do it in front of everybody else, it seems not to work. So you want to make sure that you're really good at your demonstration. So you're going to practice it during next week. Though after you get it approved, you're going to practice it. And then you'll notice that it says here, if it works, if you can get it to work, you're going to document it using a video. That would be the best way. Just like you see me videotaping now, you're going to video yourself. If for some reason video is a problem, then you're going to take some photos. One of the important photos that you're going to need to take is your before and after photos. What does your setup, your lab setup, look at before you do the experiment? And what does it look like after? So once you have everything set up out on your table or your desk or near the kitchen sink or the dining room table, wherever you're doing it, you're going to take a picture. Okay? Then you're going to videotape yourself doing the demo. So you might have to set up your camera or your laptop, or you might have to get your family to help you by pushing play and being your videographer. You're going to do the actual demo, talking through the demo, because that's where a lot of your points are going to come from. And then when you finish, before you clean up, once the demonstration is done, you're going to snap a photo. So I want to look at before and I want to see after, not just the video during. All right? And we'll talk more about what you need to be talking about as you record yourself next week as we get into phase 2. Now, here's what's going to happen next week. If it doesn't work, right? This is a red flag. Oh no, I'm trying this. It worked on YouTube. They know how to do it really well, but it doesn't work for me. I'm doing something wrong, right? So next week you'll have a chance to email me. Hey, Ms. Aguilar, do you know what I'm doing wrong? Do you have any tips? Or you can simply submit a new demo. Say, hey, mine's not working. I want to pick a different one. So we'll have all of next week to go through those details. Okay, phase 3, which will be week 14, right? Week 14. you're going to actually write your report. You're going to create a chemical demo report, according to the rubric. There is a detailed rubric, and I'll go over that with you. All 9 parts in order, follow the instructions carefully, and then you'll be submitting by the end of that week, or I think it's the following Monday. You'll be submitting, I don't remember if it's that Friday or the next Monday, but anyway, if by May 1st is the date. On Teams, you'll submit that report, which will include both the photos of before and after and the video of your actual demo. And again, if doing the video is difficult for you, talk to me and we can talk about another way of submitting that. But for most of us, a video of you doing it shouldn't be any problem. You may have to, I don't know if Teams will let us send videos that are that large. You may have to upload it on YouTube, but we'll figure it out together. We've got lots of time. All right, let's go on to the next slide. All right, so how will you be graded, right? Because this is your final project for quarter 4. Your project is 5% of your grade, but it also is an opportunity to give your grade a boost. If you need that boost, there's a couple of things we've already been talking about here. One of them was make sure that you've done all your week 10 work. Make sure that you've done all your week 11 work. Okay, everything that I put online on week 10 or week 11, make sure that you're getting it done. And then additionally, the next thing is this assignment, which covers the next 3 weeks. And then we'll be back in May with additional opportunities for work. But you want to make sure that you're not missing any of these easy opportunities. Week 10, stoichiometry. Week 11, stoichiometry and percent yield. And now week 12, 13, and 14 with your chemical project. So we'll go over the rubric, show you how to score that. That's on the next slides, and it's on your handout. And then what do I have? What resources do you have? Of course, you've got your textbook for all the chemical concepts. You've got your class notes where we learned about things like density and polarity, all the other concepts that we've covered, and then some ideas. Here's a bunch of websites, well, 3 websites, even though on the internet you're probably going to find 25 to 100 websites that would have simple chemical for kids ideas. So you want to look at this one, little bins for little hands. See, the chemical doesn't have to, the demo doesn't have to be complicated. It can be designed for a 3-year-old or a 7-year-old, but it's the chemistry behind the demo which makes it a high school project. You're being able to explain how and why it works, and that's really what I'm looking for. Not that you can just do the demo, especially if it's something that, a little kid can do, but can you teach us chemistry using the demo? That's the real question, and that's where the real points are going to come from. You'll see that in a minute. If you need to contact me in this process, make me a note on Teams. I check Teams every day, usually twice a day during the week, morning and evening, and tag me. If you tag me, it'll send me an alert. If you don't tag me, I may never see your question. You can send me an email directly. I try to check my emails from work Monday through Friday, twice a day, so you can send an email there. And if you need to just get a hold of me right away, you can just DM me on Instagram, and I just reply quickly on there. Now, if it's a long and detailed message, DMing me on Instagram probably isn't the best idea, but usually you can get a response quicker that way. But if you don't have that, no worries. Email and Teams are legitimate ways to get a hold of me. All right, let's keep moving through your handout. Chemical demonstration. All right, this is your rubric. This is going to show you how you're going to get graded. So what we have here is your 4th quarter project. Remember, I already mentioned it must be able to be safely done at home with children. So you're not looking to get any dangerous chemicals involved here. You're looking at very simple chemicals. A couple of them are a little bit dangerous, so you'll see on the list they have an asterisk that you must have your parents' permission before doing it. All right. Visually stimulating demonstration, so we have to actually see something cool. There's some demonstrations that are so simple that you can hardly see it. So unless you have an idea for zooming in really close so that the demo pops, right, you may not get approved. So it needs to be something that looks cool, and it has to be directly related to the chemistry. So if you can't teach a chemistry concept with it, it's not a good demo for you. You want a demo that you can simply teach a concept. So the total project is worth 200 points. The first 50 of those points is simply doing week 1 and week 2. Week 1 is to get approval, right? Approval by your teacher. That's week 1. Well, rather I should put it in our proper context, week 13. Week 14, you're going to make sure it actually works, right? You're going to make sure it actually works, and you're going to record your video and photo evidence. That's where your first 50 points are going to come from, and both of those are required. If you don't have an approval and you do all the rest of the project, you will get no points for the entire project. If your project doesn't work, but you do the whole report, you'll get no points for the project. It must work, and it must be approved. So that's why we've got 2 weeks just for those parts. Now, into the report, once it's worked and it's been approved, then we move on to the actual writing of the report. Right? This is the piece of paperwork that you're going to create as evidence that you have done your project. So it should be computer generated. If that's a problem, you can handwrite it. You'll only lose those 10 points out of 200. It won't be a big deal. But for typing it up, it is 10 points. Things that must be included in your report. But notice, before I get into that, it must be your work. If you copy and paste something from the internet, you're not going to get credit. It must be your work. Remember that. I've been teaching this class for 21 years, so I've been reading these reports for 21 years. What does that mean? That means I know when a report has been copied. You're like, but I got my information from the internet, Miss Aguilar. Right, so you read it and you rewrite it in your own words. I will be using the Turn It On feature on Teams, and it will read your assignment, which means what? Which means plagiarism will be noted, not just from what I'm able to pick up, but also what the system is able to pick up. So make sure that it's your own work. And again, that's required. What does that mean? Well, what if I just plagiarize some of it? Then I will give you a 0 without the opportunity to redo. Right? Once you've plagiarized, you can't be like, oh, if I don't get away with it, I'll just redo it later. There is no redo. Right? You don't want to miss this opportunity to get a nice bump in your grade by not doing your own work. Okay, I'm going to get off of that and get back on to what we were talking about, something positive here. What do I need to have? You need to have your name, CP Chemistry, period, teacher, and date at the top. That's 5 things worth 1 point each. You need to have the title of the demo. The title is usually something fun, like the one I talked about with the layers. That's usually called 7-layer rainbow, right? There might be something called genie in a bottle, maybe spontaneous combustion, right? All kinds of fun names, but they don't really tell you what the chemistry is. They just are a fun name. That's 5 points. But then under that, you're going to tell me what is the chemistry. So if you were doing the 7 layers, that would be polarity and density, right? If you were doing genie in a bottle, that would be, what would that be? Catalyst and oxidation. So you're going to actually go into the chemical concept. Then you're going to have the purpose, right? Every lab we do has a purpose. Your purpose statement is just 1 sentence, and it answers the question, how does this demo show your chemistry concept? Right? How does your chemistry concept relate to what we're actually going to see? That's it. Not a big explanation, just 1 sentence. And then your safety. And you're thinking, but this is going to be a safe project. I'm doing it at home. I know. But I still want you to list any possible safety concerns. For example, say you're going to use a glass of water. Oh, glass has a safety concern. Why? Because I need to be careful in case it shatters. Well, what if I'm just going to use rubbing alcohol? It's not that dangerous. Well, it is if you get it in your eyes, right? So keep in mind and list all safety concerns, whether they are big or small. And both of these, the purpose and the safety, are 10 points. So the points start to increase as you go down here. Then you're going to do your same chemicals and equipment T-chart. All the chemicals on one side, all the equipment on the other. Everything you will use, I better see in there. I shouldn't see anything in your pictures or your video that's not listed on this chart. And then your procedure. Your procedure in your own words. Even if you got it from the internet and you didn't make any adjustments to it, you need to rewrite it in a way that you can understand. If I see you using words and explanations that I know you don't know, then I'm going to highly suspect that it's taken from the internet. So be careful. Make sure you understand. Look up a word you don't know and rephrase it into a word you do know. All right, then the chemistry. This is the big part. Notice that this is 30 points because this is proving that you know some chemistry. In detail, explain the chemical concept and how your demo makes your concept easier to understand. So by showing me that demo, how do I now understand density and polarity, or whatever your concept is? By showing that demo, how do I now understand reduction and oxidation? How do I now understand acid and base, pH indicators? Whatever you picked. And then the last part of your report is your sources. You want to make sure that you have 2 or more links. So I should be able to click on your document and go, those hyperlinks should take me directly to the page where you got the information from. Not the website, the actual page, and that's worth 5 points. What do I mean by that? Not Google, right? www.google.com. You may have started there, but you didn't end up there. Right? Not stevespanglerscience.com, because why? Steve Spangler Science has hundreds of things on that on that website. I want to go to the exact page where you got the information from. So it links me, and it should pop open in my browser what that page is. Now, if you're not submitting it typed up, then you're going to have to handwrite that whole link out, right? So https://stevespanglerscience.com/oxidation reduction/genie-in-a-bottle.htm. The entire thing. So make sure all of it is included. All right, so that's your report. Oops, and that's 100 points. Let's go on to our next. Okay, so the actual demonstration now. What do you have to do? We already talked about showing the before and after, right? Making sure that I can see a picture before you started and after you've started. And that's 10 points each. The before picture is 10 points and the after picture is 10 points. That's why you see it like that. As you're doing the video, if you are recording it, you must discuss the safety concerns as you're doing the video. Okay? Or if you're not doing the video, you end up doing pictures, you're going to type out under each picture what are the safety concerns, because safety is a big issue. I don't want any accidents at home, anybody getting hurt. And then as you're doing the video, you need to explain what is the chemistry, why is it working, because remember, your goal here is to teach a chemistry concept, not to do a magic show. It might look cool, wow, that was cool, but if you didn't teach me any chemistry, well, what's the point, right? We're not doing a magic show, we're actually doing a chemistry class. So that's the end of the 200 points. As I said, is a 200-point project. That's the maximum points that can be earned, and that's your goal. Your goal is to get 200 out of 200 following this rubric. Once you've submitted your project this week during week 13 and I've approved it, you're going to want to make sure that you write it down, right? Which project has Ms. Aguilar approved for me? Did she approve Genie a Bottle, 7 layers? Which project? And keeping in mind that all of it put together, the video, the report is due by May 1st on Teams. All right, let's go ahead and move on here. This is a great list of chemical demonstrations that students have used in the past. You are not limited to this list, but I just wanted to provide the list to help you if you need to get started. So you're like, well, I have the list. Why do I have to do the research? Yeah, but you don't know anything about these. What have I helped you with here? I've given you the chemical concept, and I've given you some ideas of demonstrations of that chemical concept. So say, for example, you're like, hey, I'm going to do sublimation as my chemical concept. Great. Well, you've got a couple of choices. You can make ice cream in a bag using dry ice. That means you have to be able to access dry ice. Dry ice is usually available at Smart & Final, Vaughn's, they've had it, Walmart has it. So dry ice, right? It's what the paletero, right? The ice cream man uses to keep his ice cream frozen. He might sell you some. And then you have to do the safety concerns, because dry ice can be very dangerous and burn your fingers. Or you could do a dry ice bubble. What's a dry ice bubble? Well, for both of these, you go online and you do the research. You figure out how does it apply to the chemistry, sublimation, and what are the equipment that I might need to do this. If you can figure both of those out and you have them, then you can submit that idea. So that's how it works. So there's a bunch of chemical concepts here, right? These are the concepts, and then there's a bunch of ideas. So notice a couple of these say parent permission required. I will need to make contact with your parents. Either they'll send me an email from their personal email, or shoot me a text message or something letting me know that they understand the safety concerns of burning money or pickle battery before they approve it. But you are not limited. Look what it says down here. There are many more safe and easy chemistry ideas on the internet. So don't be limited to these. These are just the ones that I've seen over the years. They usually work really well and students are successful with them. So do your research, submit it for approval. Again, make sure by next Monday you've submitted this to me for approval. The steps in this whole process are reminded up here, everything we went over today. Do your research first. Make sure you have all the supplies. Get your approval by next Monday. You have a week just to do steps 1, 2, and 3. Okay? And then your final report will not be due until May 1st. All right, ladies and gentlemen, that's all I have for you today. Any questions? Make sure you see me in any one of those venues. Some people have also left some questions on the YouTube channel underneath the video. You're welcome to do that too. I also get alerts for those and can get back to you. So happy hunting. Enjoy your research as you're inside today because of that rain. It looks like it's going to rain all week. But you know what they say, April showers bring May flowers. So we should have a lot of beautiful green hills and flowers in a couple of weeks due to this wonderful rain. Enjoy yourself. God bless. And have a great week in preparation for Easter on Sunday. Bye-bye.